For most of us, driving a vehicle that has vibration can be a bit annoying. Now imagine being a cross-country truck driver with a rig that seems to be vibrating all the time. Vibration can be caused by many different rotating parts. For this video, we're going to focus on the tire wheel assembly. If vibration is a result of a tire wheel assembly, it can be caused by a runout of the assembly or an out-of-balance condition. In this video, we're going to assume that the balance is good, which has been confirmed by using a dynamic spin balancer, and the vibration is still present. At this point, we need to focus on assembly runout. Minimizing on-vehicle runout is the single most important factor to control vehicle vibration. To properly diagnose vehicle vibration complaints, you must check for on-vehicle assembly runout. It is always a good idea to check that the tire has been properly mounted. All tires have a ring molded into the lower bead area that will give you a visual indication of proper mounting. By looking at the distance between the ring and the edge of the wheel around the entire circumference of the wheel, you can see if the bead has been properly seated. Measure the distance between the ring and the rim flange in 4 places, 90 degrees apart. The maximum difference should be less than 1.5 millimeter or 1/16 of an inch from the guide ring. If the tire is not properly mounted, deflate the tire, break the bead, lube properly, reinflate and rebalance. This could solve your vibration complaint. When looking to see if the tire was properly mounted, you should also be looking for signs of tire or rim damage, as this could be the source of vibration. If there is evidence of a significant impact on either the tire or wheel, or both, replace them both. Road wear, damage, improper installation, and poor maintenance practices can all cause vibration. Even a properly balanced tire wheel assembly can have excessive runout and cause vibrations. There are 2 types of runout, radial and lateral. Radial runout is the deviation of a tire wheel assembly's roundness from a perfect circle. This causes an up and down movement of the tire wheel assembly as it rotates. Minimizing the effects of radial runout is crucial to controlling and eliminating vehicle vibration. Lateral runout is a deviation of the tire's sidewall from a perfect plane, which causes a side-to-side or wobbling movement of the tire wheel assembly as it rotates. Controlling lateral runout is not crucial, as it does not contribute to vibration. To understand and control on-vehicle runout, you will need a runout gauge. Using the gauge is important. Visual sorting or eyeballing by holding an item near the edge of the rim flange is neither accurate nor acceptable. You cannot accurately judge runout visually. Without a runout gauge, you're only guessing. A runout gauge can quickly identify which assemblies need correction. A runout gauge with a single scale, where 1 revolution equals 100,000ths of an inch, is easy to read accurately. You can measure runout precisely with a gauge and a specially made shoe or ski. This allows you to spin the tire and document the difference between the high point and the low point of the rotating assembly. Your local Goodyear dealer may be able to help you get a runout gauge, or they are often available through tire equipment suppliers. Once you have your gauge, you need to measure on-vehicle runout. The vehicle needs to be test-driven and tires warmed up to reduce the possibility of flat spotting. Measure the on-vehicle runout at the tire's center line. Once the gauge is in place, turn the tire wheel assembly slowly and watch the gauge needle. Find the low spot on the tire and zero the gauge. Once zeroed, spin the assembly slowly to check runout. Mark the assembly high spot. On steer axles, a reading of less than 60,000ths of an inch is usually good, even for sensitive vehicles. Measure all assemblies. Another factor of assembly runout is wheel runout. This can be checked on a spin balancer before the tire is mounted on it. To begin, place the runout gauge on the bead seat of the wheel and rotate the wheel slowly by hand. Goodyear's guideline for optimum ride quality is a maximum wheel radial runout of 30,000ths of an inch. You need to check both flanges, as they may be different. Once you have your runout measurements, you need to record the information. Mark the high spot of the tire wheel assembly and the amount of runout if it is over 60,000ths of an inch. Mark the stud and wheel to reference how the wheel is indexed to the hub. You will also need to mark the tire's wheel position on the vehicle. Once you have the runout measurements and have marked them on the assembly, you're ready to start minimizing runout. When trying to minimize runout on free rolling axles, place the high point of the assembly at the 12 o'clock position and loosen the lug nuts. This will allow the wheel to hang loosely. Retighten the lug nuts and recheck runout. If hub piloting clearances were causing the high runout reading, then you have just corrected for this. If the runout reading is still above 60 thousandths of an inch, you will need to match mount the tire wheel assembly as described in our video, Recommended Practices for Correcting Vehicle Runout using Match Mounting. When trying to minimize runout on dual tire wheel assemblies, the same principle applies as to free rolling axles, except now you have two assemblies to handle. If one of the assemblies has high on-vehicle runout, position the high point at 12 o'clock and loosen the lug nuts. Allow the wheel to hang loosely, then retighten the lug nuts, recheck on-vehicle runout. If the runout is still above 60 thousandths of an inch, then you can proceed to clocking duals, which can help save time versus using the match mounting procedure. Dual assemblies with high runouts will cancel each other out and provide a vibration-free ride when clocked 180 degrees apart. When installing dual assemblies, use similar runout values together. Install the assemblies with the highest runout value with its high point at 12 o'clock on the hub. Install the assembly with a lower runout value with its high point at 6 o'clock on the hub. The assemblies should have their high points as close to 180 degrees apart as possible. When clocking duals, be sure to maintain access to the valve stems. Understanding and controlling runout can help minimize vibration and make a world of difference in ride quality. An experienced technician will soon develop the skills to be able to identify a tire wheel assembly that could be the potential source of a vibration complaint by a driver. If you have any questions concerning the materials discussed or would like further information on assembly runout, contact your local Goodyear commercial tire dealer or go to our website for additional information and suggestions.